Hi guys, Miss Francis here. We left off talking about the unique characteristics of water. So I'd like to discuss more unique characteristics of water. The first one that I'd like to talk about is the fact that water has a high specific heat. And what that does is it helps us stabilize temperature. So think about it. Where are there large bodies of water? Along the coastline. And why do a lot of people want to live along the coastline? Because along the coast, the temperature fluctuates less. On a hot summer day, if you go into the city, it's much more hot than if you were to be on the beach. And that's due to the fact that water has a high specific heat. Well, why does water have a high specific heat? Because of the hydrogen bonds. It takes a lot of energy to break all of those hydrogen bonds. What impact does this have? Well, it impacts both the environment of the Earth as a system as well as the individual as a system. So first of all, as the Earth as a system, what the water's high specific heat does is that it helps regulate the water temperatures. As far as an individual goes, it helps our body not fluctuate in temperature that rapidly. So we don't decrease in temperature super fast and we don't increase in temperature super fast, which is really important for our enzymes. Our enzymes are essential for all of our chemical reactions, which is essential for us in maintaining homeostasis. So if our enzymes denature, and that happens when our body temperature gets too high, we cannot do our regular chemical reactions, which means homeostasis is thrown off balance, which isn't good for us. Water also has a high heat of vaporization. So taken together, the fact that water has a high specific heat and a high heat of vaporization, we call these thermal properties. So what does that mean to have a high heat of vaporization? It means that it's going to take a large amount of energy to break the hydrogen bonds in water in order for it to change from liquid into water vapor. So why is this important for the Earth as a whole and for individuals? Well, it's important for the Earth because if water didn't have a high heat of vaporization, then all of our lakes, our ponds, our streams, our ocean would evaporate. And as far as the individual goes, we would not be able to stay hydrated. All of our water would again vaporize. Evaporative cooling is the fact that as a liquid evaporates, it takes with it heat, and on the surface is a liquid that remains behind to cool. So when we look at humans, let's say our body temperature rises. Our brain picks up the fact that our temperature has gone up, has increased, and we start to evaporate the sweat, causing our body temperature to fall, and that is the end of that stimulus. Then let's say our body temperature falls. That stimulus is picked up by the brain, and now we start to shiver. As we shiver, our muscles start to work, and that's going to generate heat or generate energy. Stephanie Castle does a really nice job of summarizing the important properties of water. My suggestion is to know at least 3 properties of water, be able to define the property, explain the property, and discuss why that property is important to life on Earth. These are 2 chemicals that you should be familiar with. The one on the left is water. The dog is making a little appearance today. The one on the left is water, whereas the one on the right is methane, and you should note some key differences. Water over here is not symmetrical, whereas methane is symmetrical. And what that implies is that water does not share its electrons equally. Therefore, it's going to be a polar molecule. On the other hand, methane is symmetrical. It does share its electrons equally. So it is going to be a non-polar chemical. So what would happen if this methane, this non-polar chemical, replaced water in living organisms? What would happen? Well, a lot of things would happen. First of all, water makes hydrogen bonds between molecules of water, which enables it to have the unique characteristics such as having a high specific heat and a high heat of vaporization, because it takes a lot of energy to break those hydrogen bonds and change the temperature of water, or to change that water from a liquid to a gas. On the other hand, methane is non-polar, so it doesn't make hydrogen bonds, so it doesn't take a lot of energy to change its temperature or change its state. So methane has a lower high specific heat and a lower heat of vaporization. So what does that mean in the context of the Earth and the context of us as individual organisms? There's no hydrogen bonding, there's no cohesion, there's no adhesion, so water couldn't move up against gravity. There would be no photosynthesis. There would be no oxygen or food produced by autotrophs. And because I don't have that high heat of vaporization, I don't have that high specific heat, all of the seas would evaporate. We would completely dehydrate. We would die out. There would be no life. So water is really the key ingredient to life. Another unique characteristic of water is the fact that it's less dense as a solid than as a liquid. So water at temperatures above 4 degrees Celsius behaves like any other liquid. It's going to expand when it's warm and it's going to contract when it cools. However, as temperatures decrease, a unique thing happens. So ice starts to melt around 4 degrees Celsius, and what happens is the hydrogen bonds are breaking, and that allows some of the water molecules to slip closer together, making that liquid more dense than when water is frozen at 0 degrees Celsius. What happens is these hydrogen bonds are locked into a crystalline lattice that makes the ice actually less dense than the liquid water. So why is this important? Well, think about the winter. Think about a lake. What would happen if the ice was more dense than the liquid? Well, ice would sink to the bottom and the top would be completely exposed to the elements. So because the ice floats on the cool water which stays below, that enables aquatic organisms to be able to survive during the months where the top is frozen. So we have one last property to discuss, which we will get to tomorrow, and I have some vocabulary words that I would also like to discuss with you guys. See you then.